Good morning, everyone. I hope you're doing fine and ready for week's 4 summary. This is the last summary we're going to have as we're wrapping up the last 4 lectures of the course. Good morning to Venkatesan, good morning to Piyush, good morning to Elio, to Sinti, and marhaba to Ali. All right, awesome. So this is good. All right, we'll wait a minute or so. I'm so sorry that the streaming is not starting at 12 precise. I'm very French in when it comes to this. Let me fix the camera a little bit. I'm very French when it comes to this, and I click press always to start the live stream at 12 noon. But I'm always faced with this like coding and whatnot. So as soon as this month is over, as you know it by now, I'm gonna switch to a weekly mode. So it's gonna be like an hour-long weekly episode, and I'm gonna be trying some other systems. So we'll see how that goes. Good morning. Hello, Katerina. Hello, Allah. If you can tell me from which country you guys are logging in, that would be awesome. Just throw in the country. I love to see how this word is spreading. Bonjour, Sami. How this word is spreading all over the world. So this is good. All right, so it's Sunday. It's a relaxed lecture. Basically, we're going to look at the summary of our whole week, and we're going to try to see, if we finished up good, if we learned some. We've had so many exciting stuff. And hello, Sant from Turkey. All right, awesome. India, I can see. That's awesome. Greece, feta cheese. I love feta cheese. North Germany. Sehr gut. Hallo, wie geht's? Ich bin sehr gut, aber mein Deutsch ist nicht sehr gut. Saudi Arabia, ya alf ahla wa sahla. Canada. So Canada, it can be English, or ça peut être en français aussi. All right, so this is fun. That's awesome. And Rwanda, I have no clue what they speak in Rwanda. So ألف أهلا وسهلا من لبنان, Elio. I have no clue what's the language. What's the official language of Rwanda? Nepal. Hello, that's awesome. All over the world. Cool. This cannot be any better. This is so international. All right, awesome. So let's go ahead and get started with week 4 summary and looking into what we have accomplished this week. This week has been crazy. We are supposed to have sessions of 15 minutes, and we've had sessions of an hour, of 50 minutes, but it was just so exciting and we couldn't stop, and we have 2 special guests. So the United States and South Germany. I have one of my best friends living in South Germany. Bonjour, depuis la France. Bah, Andreas, je sais pas si tu le sais, mais j'ai vécu 4 ans en France. And Nicholas is my best friend from Columbia, South Carolina. That my best friend that I have not seen in almost 2 months now due to this social distancing. But hey, looking forward to see you, Mr. Saikali, soon with your family. Rwanda is Kinyarwanda. Okay, I learned a new thing. That's awesome. All right. Alain, can you put for us like how we say hello in Rwanda? That would be awesome. All right, I'm gonna go ahead and get started with our lecture for this week, for today, the summary of this week. So we covered so many things. We went into details, like we drilled down into automated fiber placement. It cannot be any better introduction for anyone who wants to get to know about this fascinating world of automated fiber placement. This week we went through defects. So what are the manufacturing imperfection and manufacturing quality that are problem? We went to inspection, and we talked about different systems, porphyrometry based, thermography, and all of these different ones. We delve into process planning and I showed you a little bit in depth my research when it comes to process planning. And then we had two lectures, three actually. That's awesome. We had three live folks from CG Tech that we looked at VCP, Vericut Composites, and VCS. We looked into the software and we looked into how you think about programming for AFP. Then we moved with ACMA and talked about with Andrew about certifications and the certification process for composites. That was a big learning moment also for me. And finally, we did a case study with NASA's Jake Turry, and we looked into the manufacturing of AFP in wind tunnel blade. All right, so let's go ahead and start with the questions. And which of these defects is the most common during AFP manufacturing? Is it wrinkling? So is it this defect? Someday I'll do this lecture from my office and I'll have all these, I have all these fancy 3D models of these defects. So is it wrinkling? Is it bridging? So when you don't have enough compaction? Is it gaps, overlaps, or is it fold? So go ahead and press for us A, B, C, or D. And in the meantime, I'm looking at the awesome messages I'm getting from everyone. So how we say hello in Rwanda, it's Amahoro. So hey, Amahoro, everyone. All right, and hello, Margaret. All right, I can see the answers trickling in. So many of you are answering gaps and overlaps. That's perfect. This is correct. Let's see. Sammy, this is correct. Pratik, Margaret. So Apurv, it's not D. The fold process, this is the fold. The fold is not such a common defect that we can have. So the fold is when the toe folds on itself. It is a defect. It can happen, but it's not at all. If actually out of these four elements, I would put fold. So if I want to do a ranking, gaps, overlaps, then wrinkling, then bridging, then fold. So let's see a little bit some of the answers we've had. Cynthia, that's correct. Katrina, correct. Piyush, Andreas, Elio, Ali, Sami, Pratik, Margaret, and Venkatesan. This is awesome. All right. So let's move on to question 2. Which of these defects is most likely to happen at the end of a course? So remember, we've seen this so much this week, all this manufacturing. So you have the course. At the end of the course, what can we have? Can it be a FOD? I don't know, this waves of clapping and likes that I'm seeing. It's awesome. So yeah, this is cool. So which of these defects is most likely to happen? Is it FOD, a foreign object debris, a splice, a twist, or a wandering toe? A toe that sways away from where it's supposed to happen. So let's see your answers. A, B, C, or D? All right, Cynthia, D, that is correct. So FOD is, Piyush, is most likely to happen, but not at the end of the course. Like it can happen anywhere. It's a foreign object. Katerina, wandering toe, that's correct. Elio, D, that's correct. Andreas, that's correct. D, correct. Pratik is correct. That's awesome. All right, so yes, it is a wandering toe. And keep in mind, wandering toe is when the toe towards the end, because you're not holding it under tension, it wanders a little bit from its location. All right, true or false? So now moving on to the second lecture. True or false? Inspection and rework accounts for a major portion of machine downtime. Is this true or is this false? So let me know, what are your thoughts? And let's see a little bit. What's going on. I'm looking into your messages. I love this dynamic session that we're having together. I'm giving a round of applause myself to all of you. All right, so let's see the answers. True or false? All right, Andreas, you're answering A. Cynthia, A. Let's see if I see a wave of A's. And then in return, I will give back in A myself, because that is definitely true. It is estimated that 30% of AFP is actual placement and 70% is rework and machine inspection and downtime and all of these different elements. I see some new folks have joined us. Hello, Manfred Ostertag. So that's awesome. All right, cool. So it is true. There is a lot of downtime coming from placement, and we need to profit from the inspection. All right. When inspecting, so this might be a little bit tricky, and it's a bit an unfair question if you don't remember the lecture. But when inspecting using thermography, the highest temperatures will appear at which of these? Overlap, temperature will not change, definitely temperature will change, or gap. All right, so if you don't remember the lecture, actually, because the overlap is closer and that has more thickness, it will take a little bit of time for the temperature to appear. Whereas the gap, it's like there is this void, and this will enable. So I'm going to answer this as the gap, just because it's a little bit too tough as a question, and it's a little bit if you don't really. Okay, that's excellent, Katerina. You already answered it the right way before I said it, so that's awesome. Cool. All right. So you know what? I misjudged all of you. All of you know that what's the right answer, and you guys are putting it on the screen. So this is perfect. You know what? Round of applause from me to all of you. This is awesome. Here we go. All right. Awesome. Moving to question 5. So this is day 3 when we started talking about automated fiber placement process planning. So how we create the curve, how we get the curve. So this is an easy one. So which reference curve would you use to limit steering? Is it a fixed angle? Remember, you do the intersection between the complex geometry with a plane. Is it a variable angle? Is it a constant curvature? Or geodesic, a bird line from one point to the other? So geodesic is straight line. Remember, steering is when you have angles. So which reference curve would you use to limit steering? I'm not saying that this is the best method. I'm saying if your requirement is to have no steering, which one would be the reference curve that you would use? Let's see a little bit the answers. Andreas, you got it right. Ali, Piyush, Katerina, Apurv. Very good, Apurv. You got it right. D, Sinti. All right, awesome. So this is correct. It is a geodesic pass. The geodesic pass actually gives you like the shortest pass between 2 points, but it doesn't really give you the angles that you want. So it really depends what is it your requirement. If you remember, and you're gonna see it in a little bit in summaries of CG Tech's presentation by Mr. Colvin, you have to decide. You cannot have it all. So Venkatesan, that is correct. Manfred, that is correct. Awesome. Moving to the last question before we look at a summary of the 3 special presentations we've had. When using the shifted curves strategy on a complex part, so we are we had some kind of issue on this when it comes on during the lecture. So we are building on a complex part. The fiber directions of offset path are not guaranteed. And the answer to this one, as you guys are trickling it, is true. All right. So this was the first part of the week, Monday, Tuesday, and Wednesdays. We had these lectures. And then on Thursday, Friday, and Saturday, we had 3 live lectures. We had the first one from CG Tech by Andre Colvin, and this is from his slides. This is a great reminder of the intended shape versus the final shape that you want. So, and keep in mind, looking into, you know what? I don't know what's the name of this game in English. Is this a teeter-tot? If you can tell me if you know the name of this game. But basically, this game, if you're going down here, you're gonna go up here. So stagger, apply angle deviation. Overlaps, gaps. You cannot have no gaps and no overlaps unless you're doing a flat plane. So I'm looking a little bit to see, if one of you know the name of this game. I've played it a lot. I did not have a rough childhood, but I forgot the name of this game. All right. Then we had. I'm waiting for your information. Just you guys are gonna teach me a word, and then we went to ACMA's lecture on composites, and we understood that no one size fits all certification of materials. Composites are extremely versatile, and sometimes existing standards are restrictive. You have to know the market, you have to know the product, and it's the best way to meet all the requirements. And we wrapped up the week with the awesome Gaze study on the AFP of a wind tunnel blade. We took a look with Jake Turey from NASA to how we use the AFP machine, how we use the wind tunnel blade, and all of these different elements. CISO, yeah, I think the CISO is only one of them, right? Apurv. So I don't know. I guess I'll do some search on this. All right. So tomorrow's lecture is gonna be a little bit intense. It's gonna be it's gonna be the only lecture where I delve a little bit into some of the matrices and some of the computation for composites. That's not the goal of our course, but I just wanted. Our goal is to introduce you to the world of composites design, world of composites manufacturing, talk with a couple of companies, and try to like at the end of it, you're no longer a beginner in composite, you're actually at the intermediate level. So the goal tomorrow is to show you a little bit the other side of mathematics behind composites. And I do have detailed videos that I use in my class. So if anyone tomorrow after the lecture, like, I'm a little bit confused, I'm ready to delve a little bit more into details. All right, so this is the end of it. This was a great interactive. Let's see, send live. Now you got me on the full screen. And I'm gonna put the logo of bottom right. And I'm gonna put the logo of my research team, and we'll see how that if it goes live. So tomorrow, we're delving into design, and then we're wrapping up with a couple of interviews. This is our last week next week. Thank you so much for this opportunity. This has been nothing short of amazing. And all the best for your Sunday. Have a great Sunday. And we talk again tomorrow at 12 noon. If I'm late a couple minutes, I'm not late. It's that system that I keep pressing go live and it doesn't want to go live. And I'll be testing something else soon. All right, bye-bye. Thank you so much, and have a great rest of Sunday.